Hi, this is Alex from devstories.eu, GeoPandas, Episode 1 of 11. Traditional geographic systems usually force you to keep exactly one geometric shape per file, meaning if you need the border of a county and its center point, you must maintain two separate files. GeoPandas breaks this constraint, letting you store borders, center points, and buffered zones side by side in a single table. Meet GeoPandas, the active geometry column. GeoPandas is an extension of the data analysis library Pandas. It takes the familiar data frame and series structures and adds spatial capabilities. Under the hood, GeoPandas acts as a bridge between tabular data and spatial geometry. It manages the table structure itself while it delegates the actual mathematics of points, lines, and polygons to a spatial engine called Shapely. When you ask GeoPandas to calculate an area or find a boundary, it passes the relevant shapes to Shapely, retrieves the mathematical result, and aligns it right back into your data row. The two core data structures making this possible are the GeoSeries and the GeoDataFrame. A GeoSeries is a single column where every row holds a Shapely geometry object. A GeoDataFrame is a standard Pandas data frame that contains at least one GeoSeries column. Because a single GeoDataFrame can hold multiple spatial columns at once, the system needs to know which one to target when you run a spatial command. This is managed through the active geometry column. Here is the key insight. The active geometry column is a functional state, not a specific text string. Users frequently confuse a column literally named geometry with the underlying concept of the active geometry column. By default, when loading data, GeoPandas will look for a column named geometry and assign it the active status, but your spatial columns can be named absolutely anything. What matters is which one holds the active status, because spatial methods are routed specifically to that active column. Consider a dataset of local counties. You have a column called County Borders storing the complex polygon outlines of each region. In the same table, you have another column called County Centroids, storing a single dot in the middle of each region. If the Borders column holds the active status, asking the data frame to calculate the area will return the full square mileage of the county. Any distance calculation you run will measure from the outer edge of that county border. If you want to measure the distance between the center points of the counties instead, you change the spatial context. You call a method named setGeometry and provide the name of the centroids column. Immediately, County Centroids becomes the active geometry. The Borders column remains perfectly intact, holding your polygons, but the system now treats it as just another column of data. If you run a spatial calculation now, GeoPandas automatically targets the center points. You switch between spatial contexts instantly, without merging tables or managing duplicate datasets. The most useful takeaway is that a GeoDataFrame is a spatial container, capable of holding as many geometry layers as you need, but the active geometry dictates which spatial tool is currently engaged. If you enjoy the podcast and want to help support the show, you can search for DevStories EU on Patreon. That is all for this one. Thanks for listening and keep building.